Welcome to Nevia's Cooking Show. Today we're going to be making stuffed peppers. So what you want to do... Pain. What is pain? Is it a signal that tells our body something is wrong? Or can pain hide deeper secrets? Let's find out. So, how does pain travel through our body? There are special nerve endings called nociceptors, which are only activated by a painful stimulus, like a cut or a pinprick. When cells are injured, they release chemicals that are picked up by these nociceptors. Let's trace it from the beginning. The information from nociceptors reaches the spinal cord by the first-order neuron and is then transferred to the second-order neuron. This crosses the opposite side of the spinal cord, which is called decussation. The second-order neuron travels upwards through the spinal cord and brainstem. This path is called the lateral spinothalamic tract. Another exchange of information happens and signals reach the third-order neuron that ascends to the somatosensory cortex, a special part that receives sensory input from the body. Different parts of the cortex correspond with different parts of your body. The third-order neuron takes the information and brings it to the spot in the cortex where the hand is located, because that's where the cut is. Think of it like your brain has a detailed map of your body so that it can figure out where the signal originated from. The map is called homunculus and looks pretty weird because some regions like the tongue and hands have a larger representation than the rest of the body. Some stimuli, however, need an immediate response, like touching your hand on a hot pan. Instead of the first and second order neuron exchanging info, the first order neuron takes the signal to the relay and motor neuron in the spinal cord. This sends a signal to the muscle to contract and pulls the hand back. The reflex path is like a bypass, in the sense that it's faster than the usual path pain travels in. Did you know that 60 to 70% of amputees still feel pain in their severed limb? Ow! This condition is called phantom pain, and can be a really big problem. Can we figure out why phantom pain happens? Researchers are still not sure, but we know it has something to do with the way information is processed in the cortex. When limbs aren't present, the surrounding region's nociceptors become more sensitive to stimuli, and the size of the limb in homunculus increases. There are many ways to try and shrink the size of the phantom limb in the cortex, but the most common is mirror box therapy. You place the amputated limb behind the mirror and the other limb in front of it. This gives the perception that both limbs are intact and decreases the amount of sensitivity. Now we learned how pain travels through our body and broke down the science of phantom pain. We've seen just how important pain is for our physical health. After all, no pain, no gain.